So you all seen the spotlight challenge there?
Yeah.
Alright. Get ready. Ready, set, go. And by the way, I should tell you guys that this number over here is actually one big mixed number. And you know, like how you just have 2.5, that's a mixed number. Well, you have this big 2 over here, but then the fraction actually have other fractions in there for you to work out. So just letting you know, this is a mixed number, right?
Like under 5 minutes.
5 minutes? No. We have a class to do. Alright, you already had 20 minutes there. 19 minutes, right? So let's. Yeah. It's been a lot of time, man. So at the end of the day, I have a lot of brackets here. This is like the Godzilla of bot mass. And we can see that I have a huge mixed number here. So let's start right there. I need to know what this mixed number is, so I'm going to work out the numerator and the denominator to find out what the fraction is. I can see that these two fractions are being multiplied, so 2 into 2, 1, 2 into 4, 2, right? 3 into 3, 1, 3 into 6 is 2, and then these two cancel, so this numerator ends up being 1, yeah? If we look at the denominator, 5 into 5, 1, 5 into 15, 3, 1, 9 is 9, 9 3s are 27, 3 into 3, 1, so this denominator ends up being 1. So the mixed number that we have here is actually 2 and 1 over 1. What does that equal to? Why 3? Right. So remember what a mixed number is the whole number plus the fraction. So if I had 2.5, what that actually means is 2 plus a half. Right? So that's what a mixed number means, right? So I had some students who wanted to multiply it. 2 times 1 is 2. But in a mixed number, it's not multiplication, it's addition. So it's actually 2 plus 1. Now, if you wanted, you could also work out this mixed number by changing it to an improper fraction. 2 times 1 is 2 plus 1 is 3 over 1, which is 3. So this huge number here, the whole thing is actually 3, this part here. So let's work out this part here. A quarter plus 15 on 20. Now if I have 15 on 20, 5 into 15 is 3, 5 into 20 is 4. So this becomes a quarter plus 3 on 4. A quarter plus 3/4 is 4 quarters, which means that this entire thing is 1. Yeah? Over here, I have 6 into 6, 1, 6 3s are 18. So 3 divided by 3 is 1. So this entire thing here is 1 over 1, which is 1. So therefore the numerator is 3 minus 1, which is 2. Alright, did anybody work out that 2 for the numerator?
Yeah.
Alright, what about you, Caitlin? Where did you go wrong?
Instead of putting 1 1 for the first part with mixed number 2, I just left it as 2 and 3, and I mistakenly put it there instead of 1.
So you left it as 2?
Yeah.
Oh, I see. Instead of 3.
Yeah.
All right. Yes. That's not. Yeah. That was a little tricky little thing there. But the cool thing is that I'm sure you learned something there, right? So so now we have the dividing, right? So 2 divided by what? Well, let's work out these big square brackets on this side here first. I have 6.5 into 13 is 2, plus 8 on 16, well, that is a half, and 13 on 26 is also a half. So this is a half plus a half. This turns out to be 1, right? Now 3 minus 450 over 225. I hope you realize 25 is a half of a 50. 2 is a half of 4. So therefore this into this 1, this into this is 2. 225 into 450 is 2. So 3 minus 2 is 1. So therefore this part here is actually 2 plus 1, 1 over 1, which gives me 3. Anybody worked out this to be 3?
Yeah.
Alright, I have 1 here. How about you, Scotia? Scotia still there?
I'm checking.
Right. Well, so this whole part is 3, and then 3 is going to minus something. So what is this? Well, we see this ugly business going on top of here, but we could realize that they're both to the same denominator. So that means that we could just minus the numerators as normal. 389 minus 113, and that is 276 over 138. We keep the same denominator. So 276 over 138, this into this 1, this into this 2, right? Divided by 138. So on top of here is actually 2, yeah? And then underneath here now, we have, well, 13 into 26, because it's a multiply, so I could cross multiply. So 13 into 26 is 2, 54, 1, this into 108 is 2, 2 into 2, 1. So this entire part here ends up being 1, right? 2 into 2, 1, so that's 1 times 1 is 1. So this 2 divided by this 1 means that this is 2. So the denominator is 3 minus 2, which is 1. So therefore, the answer to the Spotlight Challenge is 2. Scotia, how you feel about this?
I got the numerator.
You got the numerator, so that is
That
cool.
was kind of it.
And what were you doing for the denominator? Were you getting it right, or
I honestly don't know what happened.
you don't know what happened? But do you understand what I did there, though?
Yeah.
Right? Did you just minus this 1 to the 8th thing to get this, or did you find LCM and things for that and didn't notice that the denominators were the same?
No, I don't know anything.
Alright, okay, good. Alright, so be careful. I actually am not pleased with both of you all on your performance in fractions. And I know that I given you some. I mean, look at this question. This question is ridiculous. So I know I given all you tough stuff. Yeah, I know that, right? But I'm actually not happy really with what you guys have been doing with fractions. So I didn't want to do any fractions questions today, but I really just had a check. I really just had a check, right? So just now. And I think we did some of this last class. So just do this number 6 here, and let me see how you make out with that. Say done it as soon as you finish.
Let's got an answer.
Alright, so we have 1. Caitlin, how about you?
Almost finished.
Almost finished. Okay. So obviously we have to tackle the brackets first, right? So we're definitely gonna do so. We'll leave this guy here, or maybe we could convert it to an improper fraction one time, but we'll see, right? But let's just tackle inside this brackets first. We can see it's a BODMAS situation where we have the divide. So we have to do this divide first. So we'll leave the negative there and handle that divide. So we'll have now 3 and 5 over 9 plus brackets 1 over 6 minus, and then we're going to handle this divide here. So 4 2s are 8 and 1 is 9. So this is really 9 on 2, this here. So 3 over 4 divided by 9 over 2 is really 3 over 4 multiplied by 2 over 9, right? So 3 over 4 multiplied by 2 over 9 gives us 3 into 3, 1, 3 into 9, 3, 2 into 2, 1, 2 into 4, 2. So this is 2 3s. You just multiply your numerators and the denominators now. 1 over 6. Oh my goodness, well, look at that. So we have here 1 over 6 minus 1 over 6. Well, this gives us 0. So the answer is 3 and 5 over 9. Did you all get that?
Yeah.
Alright, okay, yeah, that's Caitlin, yeah? How about you, Scotia?
Nope.
What did you do wrong?
Something so stupid.
What? What did you do wrong?
Minus 316 can be 3 over 4 thirds.
Oh, you do this first.
Yeah.
Right, so this is the purpose of the BODMAS, yeah? So the BODMAS, you have many operations in there. What do you do first? So BODMAS means you have to do your brackets first, and then second is anything to do with multiplication and division, and then you do your addition and your subtraction last. You understand that, Scotia?
Yeah.
Right. So just remember that. I don't like these tiny little mistakes here. So let's try this one, number 10. I'm not sure if I gave you this question before, but let's see if you do it. You only have 2 minutes to do this. I think I did give you this question last week, right?
I'm multiplied first.
This here, right?
Yeah.
Yeah, very good. We could think about this being in our brackets. We could think about this being in our brackets. And we could also think about these being in our brackets. Right? So we could think about these brackets here. And obviously this divide will do after you do the brackets, because BODMAS say you had to do your brackets first. So we'll do this multiplication first. So we could see 5 into 5, 1. 5 3s are 15. 9 3s are 27. So that's 1 minus 7 over 27. You all got that for your denominator? Right?
Yeah.
And with the numerator, remember we were saying it have a generalization. 9 times 15 is I could go 135 over here, right? And then what do? We cross multiply. So 9 times 7 is 63 minus 5 times 15 is 75. Now you can see here we cannot cross multiply here because this is not a multiply, this is a negative sign. So you can't just cross off the 5 and the 15. You had to multiply them. So therefore what do we have here? 75 minus 63 is equal to 12 over 135. And all of that is being divided by 1 minus 27. you can really think of this 1 as being 27 over 27 minus 7 over 27. So that gives us 20 over 27. Right? And you know, when we are dividing, is really just invert and multiply. Multiply by 27 all over 20. So can 27 go into 135? Yes, it can. 27 times 5 is 135. So 1, and this is 5, and 12. How will 12 work over 20? Well, we can see here that what do we get when you cancel 12 and 20? 5 4s are 20 and 3 4s are 12. So I can get 3 here and I can get 5 here. So now 3 times 1 will give me 3, and 5 times 5 is 25. And this cannot be simplified further. So this is the final answer. How are you feeling about this one?
Good.
Alright. Scotia?
Nothing.
Why? What will you do this time?
CSEC denominator.
What problems did you make with the denominator in terms of this minusing over here? When you did this multiplication, did you get 7 over 27? Alright, so it's 1 minus 7 over 27, right?
Yeah.
So what did you do? How did you work that out? All of these errors are good. I'm not shaming you or nothing. All of these errors are really good because with each error you learn something, right?
I think I left out that one.
You left out the denominator?
Yeah.
How do you mean you left it out?
One of these 4 things, I mean just 1.
Oh, you left out the 1, so you just had minus 7 over 27?
No.
Alright, okay. Do you see what you did wrong? Do you understand what you did wrong?
Yeah.
You understand what I did here? Alright. So ladies, I am not really happy with your work on fractions. So these 2 pages on fractions, you're definitely going to have to do for me for next week. Well, not for next week, for next class, for Saturday. These 2 pages on fractions you'll definitely have to do. And I just want to see all of the working for it, just to ensure what you're doing. We will some of these things we already did actually. Some of these ones we did last week. This question right here, we did this last week. Yeah? So well, last class, right? So these fractions things we need to sort it out, Scotia, because algebra you'll meet fractions with algebra. So you'll have to know what to do, right? So when we're talking about fractions now, right? What are some of the types of fractions that we were talking about? The first type is what?
Proper.
Right, so we have like a half, which is proper. And then the second type is what?
Improper.
Right. And then the third type is?
Mixed number.
And then the fourth type is? There's a fourth type and a fifth type. And the thing is that you know what it is. But I don't know if you knew, or if you know what it is, you know it's a fraction, but I don't know if you ever actually considered it under the type of fractions. But one of them is the decimal. Isn't a decimal a fraction?
Yeah.
Right. And the other one is the percentage. The percentage is a very special type of fraction, right? It's a fraction that we put over 100. So today we are actually going to be talking about decimals and percentages. But young ladies, I'm really not that happy with your performance on fractions. So I'll have to see what it is are they doing for this assignment, and then maybe we might have to do over that class on fractions. However, please remember that all of these classes are being recorded, and if you go in your Google Drive, it'll be uploaded by tonight. So if you go in your Google Drive, you'll see that. So please look over the lesson on fractions and make sure you remember how to deal with your fractions, right? So what is a decimal? We know that a half could also be written as what? Where's a half as a decimal? .5. 0.5. Caitlin, you knew this, right?
Yeah.
Alright, why didn't answer, Caitlin? Yeah, right. So, my question is, how do we get from here to here?
Here to divide the denominator by the numerator.
Right. So we have to remember, whilst we could think about fractions as many different things, we could think about a fraction as like in terms of a pizza, where I have 2 slices of pizza, right? So 2 is the total, and if Caitlin come and thief 1 slice of pizza, then I only have 1 out of the 2 slices of pizza. So we could think about a fraction like that. But another way to think about a fraction will be an actual division. If 2 is actually dividing 1, right? So we actually do the long division here, where we actually have to take the 2 and we actually have to divide, take the 1 and divide it by 2. So how do we do long division? Anybody remember? How do we do this? Caitlin, you did not win the spotlight challenge, so you are not exempt. So how do I do long division? Remind me.
2 times 2 go into 1.
And how many times can I go into 1?
2 times?
No, 2 can't go into 1 2 times. 1 could go into 2 2 times. I have 2 1s inside of 2, and yeah, I have 2 1s inside of the 2. So, but 2 can't go into 1. How many 2s do I have inside of 1? None. And?
Yeah.
So 2 cannot go into 1. So I have to put a 0, right? Yeah. And where I put that 0, I have to put now a point. Yeah. And with that point, I can add a 0 over here. And now I could say, well, 5 into 2 is, right? Oh, sorry, you have to put the point here too. My apologies. Let me just do that over, right? So 2 can't go into 1. So you put the 0 and then you put a point. You have to put your point here too and add a 0, right? Now 5 multiplied by 2 is 10. But we have this 1.0 here. Why didn't I put actual 10? Why? How did I work that out? What is this? Watch. 2 multiplied by 5. What is that?
10.
What is 2 multiply by 0.5. Caitlin?
1?
Yes, not 1, 1.0. At the end of the day, what you do is you multiply the number as normal, but then you look at the amount of decimal places in the question itself. So how many decimal places we have in the question? We have 1 decimal place. So you multiply the number as normal, and the answer, so 5 times 2 is 10, but then you put 1 decimal place. Make sure that one of those digits are behind the decimal point, right? So what about this? 2 multiplied by 0.05 will give me what? Same thing I was just talking about. What do? First you multiply it normal. When you multiply normal, what do you get?
0.10.
Well, not 0.10. You just multiply the 2 by the 5 and you'll get 10, right? And then you look at how many decimal places are in the question. We can see here that we have 2 decimal places. So I need both 1, 2 decimal places. So it's 0.10. Scotia, you following this?
Yeah.
Caitlin, you're okay with this, right?
Yeah.
Well, let me see how okay you guys really are. What about 0.2 multiplied by 0.5?
Zero point
0.1. Yes, that's true. You multiply the 2 and the 5. So 5 2s are 10, right? And then you check to see how many decimal places you have in the question. I have 1 over here and I have 1 over here. So that's 2 decimal places. So I'll go 1, 2, put the point there. So it's 0.1. These two are actually the same, right? So everybody understands how to multiply these decimals in terms of the decimal spaces.
Yeah.
So now we could see when we come here that, yeah, 5 2s are 10, but it's not actually 5, it's 0.5. So whilst 5 2s are 10, I need to put that 1 decimal space there. Alright, so now this becomes 0. You guys understand this? Alright. I hope you guys writing this stuff down. You write it down?
Yeah.
Alright. Scotia, you wrote this down?
Yeah.
Everything that I write down, you have to write down. I am not writing down for kicks, you know? So, let me get this one. Just now, let me see. Right. Let me get this one here. Change that fraction into a decimal.
I got an answer.
What is the answer you got?
7.75.
Alright, so let's check it out. So the 31 is being divided by the 4. So can 4 go into 31? Well, 7 4s are 28. And 31 minus 28 is 3. So can 4 go into 3? No, it cannot. Right? So, can 4 go into 3? No, it cannot. So I'll put a point there and I'll put a 0 here. Right? So can 4 go into 30 now? Well, I'll have to put this point here too. Sorry about that. I keep doing that. I keep making the same mistake. So once you put the point here, you put the point here. Right? And you add a 0. So you're thinking about it as 30. right? So can 4 go into 30? Well, 7 4s are 28, but remember it's 0.7. So when you put the 28 here, you'll have that point there, and so you'll end up getting 0.3, yeah. And well, this 4 can't go into this. Wait, no, sorry. Scotia, you could have told me I got that wrong. 0.2, right? Yeah. So now you add your 0 because 4 can't go into 2. So you add the 0, make it a 20, and then you go 5 now. 5 4s are 20, but look, it's 2 decimal places you're dealing with, so it's 0.20, and you get 0 there. But notice that once you put this point remains in the same place right here. Caitlin, you get through with this one?
Yeah.
Alright, so are you okay with changing fractions to decimals? How do we change decimals to fractions now? What is give me this one. How do we do that?
I got 0.5.
Right, so how do we do that though? When you have a decimal, 0.6, how do you change it to a fraction? What is the first thing you have to do?
Well, I think I learned it a shorter way.
Well, tell me. How do you do it?
You see where the point is?
Uh-huh.
I just saw 1 there, then I was 0.
Right.
Like how much?
So this is actually the way that you do it, right? You put your vinculum, and then where the point is, you put a 1, and then where every decimal place that you have after the point, you'll put a 0. In this case, we only have 1 decimal place. So therefore, we have 6/10, and that 6/10 could cancel to get what? 3/5? Is that what you got, Scotia?
Yeah.
Alright, nice. So we have 3/5. Let's try another one. Let's try this one here. Oh, come on. This one here, 0.325. Caitlin, what the answer for this one? Since you are not exempt. You are the only one who submitted an answer.
This is what we do.
Right, very good. So I put this so, and I put the 1 where the point is. 3 decimal places means that I have 3 zeros. So that means I have 325 all over 1,000. Now, you could cross this off in multiples of 5, but that'll actually take too long. But what you could think about is multiples of 25. So it have 13 25s in 325, and it have 40 25s in 1,000. So you end up with 13/40. Nice. So is everybody okay with this converting a decimal into a fraction?
Yeah.
Right. Any questions?
Nope.
Well, on with it. Remember, this is just a revision of the simplest of the simplest. So let me see this one here. Kamal, you done this yet? How do we do this? Somebody explain it to me. 4.2 times 5.8. 4.2 times 5.8. How do we do it?
So much like normal, then put as many, how many places the decimal points have in there.
Right, very good. So you multiply it like normal, which means we multiply it just like how you would multiply 42 times 58. How do we multiply 42 times 58? What's the procedure here? Anybody?
You must by the 5 first and the 8.
You multiply the 5 by the 8.
No, you must by the 5 by the 2 top numbers before all the 8.
So you're multiplying the 42 by the 5 first. So 5 2s are 10. Is that what you're saying? How does that work? But do I need to put a 0 here?
Oh yeah.
Alright, and then 5 2s are 10. And I carry the 1. And then 5 4s are 20. And 1 is 21, right? And what do I do? Now I multiply the 42 by the 8, right? So 8 2s are 16. 4 8s are 32 and 1 is 33. So the answer is 2436. Scotia, you okay with this?
Yeah.
Right, you sure? Now, did you guys realize that this long multiplication you've been doing all of the time actually came from the distributive law? And I know that you all heard what the distributive law is. I know that you all heard that term before. But look, we multiplied the 42 by the 5, and then we added it to the 42 by the 8, right? So if we have 42 multiplied by 58, what did we just do? We just really split up the 58. So we have 42 and we split up the 58 into 50 plus 8. That's what we did there. And then we said 42 times 50 is 2100. And then we added this addition sign here. We added 42 plus 8, which is 336. And that gives us 2436. So did you all know that this long division, this long multiplication you were doing all the time actually came from the distributive law? Did you know that?
No.
Did you know that they were both the same thing? Right? So essentially the answer is 2436. But just as Caitlin said, we look at how many decimal places are in the problem. We have 1 decimal place here, 2 decimal places here. So we come 1, 2, and we put the point here. So the answer is actually 24.36. You okay with this, Scotia?
Yeah.
Are you sure? Alright, we are just breezing through here.
A7.5078.
Okay, I find out it'll take too long to do that though. So this is 0.78 divided by 100. So that means that going 0.0078. So this is 0.0078. And this one is multiplied by 10. So this is plus 87.5. And now we're talking about addition here. So we have 87.5 and we're gonna add it to, and you're making sure with addition and multiplication that your points are always lined up. So I'll put a 0 on this side, and now we have 0.078. So we can see here that when we adding it, this is gonna be 87.5078. Caitlin, you okay with that?
Yeah.
Alright. So this is just more working with decimals and stuff. So yes, now we finished with, well, we haven't finished with decimals yet actually. Let me just do one more thing and then we'll finish with decimals, right? If I have 547.82913562. What is this to 2 decimal places. Click.
Say out the whole number? Or?
Say out the whole number to 2 decimal places.
54,782.
Alright. 54,782. So where the decimal place gonna be?
Well,
Alright. The thing is, this isn't being multiplied by anything. So I don't know how you get 54,000. You multiply this by 100. I didn't multiply this by anything. All I'm saying is that this answer is very, very long, and I'd like to just have a shorter answer to 2 decimal places. Caitlin, what it is?
547.82.
547.82. Right, so both of you all have it wrong. This is not correct, Caitlin, but Caitlin, you are closer to the answer. Just one thing have to change. Scotia, you remember now? So you see here that I have 2 decimal places, right? Yeah? So what has to change here? Why is this not correct? Why is this correct? This is the right answer here. 547 to 2 decimal places. So I want 2 places after the point. 0.83. Why is that correct? Scotia, Caitlin, all you never do decimal places before?
yeah, I'm not sure how to explain it.
Right. So what you do is you want 2 decimal places, right? So you check the point and you check this 1, 2. That is the 2 decimal places you want. But you can't do like Caitlin and just write it. You have to check the number after. Yeah? Because if the number after is above 5, then you have to round up this number. You all remember that?
Yeah.
Caitlin, you remember that?
Yeah.
Right? So if the number after is less than 5, then you could leave it how it is. So, number 2, give me this number, but to 3 decimal places.
Five 47.829.
Right, 547.829. I want 3 decimal places, so from the point, I will check 1, 2, 3. So I want the 8, the 2, and the 9, but I have to check this number after. This number is less than 5, so that means that I don't have to do anything to the 9. I don't have to round it up or anything like that. Nice. Number 3, give me the same number to 5 decimal places.
Five 547.8291.
8291.
4.
Very good. Alright, so once it's 5 and up, you round it up. You okay with that, Caitlin?
Yeah.
Alright, so now SF is significant figures. You all ever did this one?
Yeah. Yeah.
Right, so let me see if you remember what it is. Give me this same number here, but I want it to 5 significant figures. Caitlin, you remember what significant figures are?
Okay.
So wait is, a little hammer waiting now. Here's the answer. Quick. Guess, guess, guess. Guess if you had a guess. Don't worry about being wrong. Just stop wasting time. Come on, I had to hear something. I want to hear something.
547.83.
Alright. 547.82. That is close enough. Now, when we're talking about 5 significant figures, when we're talking about decimal places, we're talking about after the point. So after the point is where you're counting your decimal places. However, when we're talking about significant figures, you're going to consider the whole number. The whole number is most important. So you want to make sure that you get the full whole number first, 547. So you have 3 significant figures there, and now you know you want 5 significant figures, so it's 2 more. So now you can start to see who from the decimal places you could take, right? And you could take 2 from the decimal places, so you know you're cutting it off there. That's 5 figures, 1, 2, 3, 4, 5. But guess what? Just like decimal places, you have to round it up. Nice? You all understand?
Yeah.
All right. So what I'm saying is that for significant figures, you have to consider the whole number too. But remember, you're still going to be rounding up that decimal. So do you guys understand the difference between decimal places and significant figures?
Yeah.
All right, good. Nice. So we're talking about percentages now. Give me the answer for that. What is a percentage?
A number over 100.
A fraction out of 100. Yes, you're correct. Right? So let me just say I have a fraction out of 100 of the total. Right? So the total is 100. But at the end of the day, let's say an example is if I have, say, 300 pairs of shoes, right? 300 pairs of shoes. And Caitlin is a renowned shoe thief. So Caitlin come and thief 15% of my shoes. How much shoes did Caitlin steal? Well, she stole 15%, which means that she stole 15 out of 100. Right? So 15% is 15 out of 100. So she stole this fraction of the total. So this is the total here. And she stole, Caitlin, your shoe thief, stole this fraction of the total. Click, click. 15 by 3 is 45. So Caitlin go on and thief 45 of my shoes, Caitlin. Right? So you understand how to work this this percentage thing, right? Everybody understand this little statement that I make here?
Yeah.
Alright. Well, since you all understand the statement, give me this question. Explain this question for me. I don't want you to do it. I want you to actually talk it out and explain it. How do we work that out? How much time do they want with it? This is a question mark over here. What is the question asking you? What information is the question giving you?
They're asking how many people had in this total.
So they want to know the total. In this case, I gave you the total. The total was 300 pairs of shoes. But in this case, we don't know the total. We know the smaller portion. We know 15% of the total is 30 people. How are we going to find the total? Caitlin.
Take away the 15% that was used to represent 50 people from the 100.
From what 100?
The entire thing of people.
But we don't know how much people it is. Right? Yeah. So what you're trying to say is take away 30 from 100?
No, the percentage is representative.
Take away 15 from 100. Right? So 15, 100 minus 15 is 85. Right? So 85, so that means that this here is 85%. How does that help us though? I want to know how much people in total. Scotia, any ideas?
No.
Okay, thank you for saying that so swiftly. What about this? Isn't 15% 30 people? Can you work it out from there now? Now that I've made this statement, can you work it out from there? Scotia or Caitlin, can you work it out from there? Yes or no?
No.
Alright, so check it out. When you see how easy it is, you'll be clawing, you'll basically slap yourself, right? 15% of 30. 15, not 15% of 30, sorry. 15% equals 30 people. Therefore, 1% will be 30 divided by 15. You agree with that, Scotia?
Yeah.
Therefore, 100% will be 30 divided by 15 multiplied by 100. Caitlin, you understand that?
Yeah.
Right? So 15 into 30 is 2 times 100, 200 people total. Does everybody understand this question?
Yeah.
Alright, good. We have some other, and I'm sorry they're kind of blurry right now. Let's just do one short one here. Alright, I know it's getting late. Apple is having a 20% off sale. So I'm getting 20% off. Right? My question is, they say I bought my new iPod for $40. They have pounds here, but let me call it dollars, right? So $40 is how much I buy it at. $40 is what I bought it at. So this is the discounted price, right? So after they give me 20% off, I paid this price, $40. What was the original price? Talk it out. Talk it out and tell me. What are you guys thinking? What kind of pizza?
$80% is equal to $40.
Beautiful. So if they gave me 20% off and I paid $40, I paid $40, but $40 is not 100% of the price because they gave me 20% off. So they have 100% the total price. They minus 20%. So that would be 80% is what I am paying, and that is $40. So if 80% is $40, 1% is 40 over 80, and therefore the original 100% price will be 40 over 80 times 100 over 1. This is 1, this is 2. A half of 100 is $50. Caitlin, how you feeling?
Good, I guess.
You sure you're good? Are you tired or are you okay?
So.
So. What about you, Scotia?
It's getting there.
Alright, so let's tackle this question. A packet of Zoomers, I can't even, Hubmobs, I don't know what Hubmobs is. So let me call it Zoomers. Are you like Zoomers? I love Zoomers. I'm getting hungry. A packet of Zoomers claims to be 24% bigger. It now contains 31 biscuits. How many did it have before? So it is 24% bigger. So it now it is 24% bigger. And now that it is 24% bigger, it has 31 biscuits in it.
$124 equals to 31.
You agree with that, Caitlin?
Yeah.
So yeah, it is 24% bigger. So originally it was 100%, but they made it 24% bigger. So that means that that have 31 biscuits. So therefore 124% has 31 biscuits. So therefore 1% is going to have 31 over 124, and then the original total is 31 over 124 multiplied by 100 over 1. I hope you are writing this stuff down. So 31 divided by 124 multiplied by 100 is 25. So it had 25 biscuits before, and now it has 31, a 24% increase. So everybody understand these percentage questions? Now I know it's not that you don't understand. I know it's just that you probably have not done them in a long time, right? Is that it?
Yeah.
Right. Now I was supposed to look at ratios as well, right? But I actually think I'm going to close it off there for today. What I need you guys to do is I need you guys to kind of revise your ratios right, with these two ratios sheets and then these percentages sheets. I'm not this one percentage sheet. I'm not particularly pleased by you guys in terms of your knowledge in fractions. I think it needs improvement, and I really want you to focus on that, as well as, you know, jarring your memory on percentages and ratios, right? And we didn't really look into ratios, but ratios is quite a simple concept, so we will deal with the ratio stuff next week. Hopefully next week will be the last class where we're doing this SCA primary school revision, and then right after that we're going to get into some algebra. Now the reason why I'm going into algebra right after is because right now we were working with number theory, we were working with computations and just adding numbers and multiplying numbers and fractions, right? So what I want to show you guys next is how algebra is actually the same thing. There is nothing different from adding fractions in number theory and adding fractions in algebra. There is no difference. So that is why I want you guys to be able to add your fractions and know your number theory, know it well, be able to handle them fractions, so that you see what we're doing right now is the problem in maths. I just keep saying this. If you could do this stuff well, nothing else in maths will give you problems, right? So this is what we're here to sort out, right? So let me just show you before we leave. Share screen. Everybody seeing this share screen here?
Yeah.
All right. If you look at the Google classwork, you know, we starting at the very beginning, so go all the way down to the bottom. That's the beginning. We working on number theory, right? This was the first class. The entire video for the first class is there. So if you want to hear yourself talking, then go and check it out. This is the second class. The video for the second class is there. So, and look at what the videos are about. This first video was basic arithmetic, BODMAS, and an introduction to fractions. This second video is where we focused on fractions with BODMAS, right? So this class is actually our third class. So I'm going to upload the third video tonight, so that by tomorrow you will be seeing the class 3 video in this topic. Now the last time you guys had to do this computations thing and you guys turned it in, right? So that's very good. So this was the first assignment that you all did, computations with BODMAS. This is the assignment that you are going to do for this Saturday. It's computations 2, right? So when you're looking for your assignment, you're looking under number theory and you're looking under computations 2. Everybody understands that?
Yeah.
All right, Caitlin, you good?
Yeah.
Now, computations 2 is basically the worksheet that we were just doing. It starts off with the spotlight question. Now, guys, I told my form 3s blowing all you out in fractions, right? In fact, I told my form 3s to skip the fractions part of this worksheet. But you guys are a different story. You know, I could see that you guys need your little bit of help and you need your little extra practice with fractions. So you know, and which is not a problem, that is what we are here for. So you know that the answer for this entire big Godzilla BODMAS mess over here, the answer for it is 2. So I definitely like you guys to rework this and get 2. And I definitely want you guys to work out all of the fractions in this sheet. You understand? These 2 fractions here. You understand what I'm saying?
Yeah.
Right. Now it's really 12 pages of questions, eh? So I don't want to kill all your one time. So yes, I want you to do all of these fractions questions, which is the first 3 pages here. Spotlight, and then these 2 fractions pages here. The rest of the pages are just a little revision. So if you want, you could do 1 or 2 questions out of each page. If you want, right? You could do 1 or 2 questions out of each page. We just did this percentage thing here. These percentages questions I do want to see. These ratio questions I do want to see. But at the end of the day, you could choose whatever questions you want to do. But you see this last page here? This last page is a multiple choice with 14 questions. I want this whole page, you understand? I don't really care if you do any questions from the rest of the paper or not, but I do want this sheet over here. Everybody understand?
Yeah.
So this last sheet here is a multiple choice, so you have options, and I want this last sheet for sure, and I want all of the first 3 pages, 1, 2, 3 pages of fractions for sure. So how many pages do you have to do for sure? Caitlin, how many pages do you have to do for sure?
4.
Very good, 4. Right? You're doing, for sure, you are doing these first 3 fractions questions, fractions pages, and for sure you're going down to the last page and you're doing this multiple choice exercise here. That is for sure. If you want to do any of these questions in the middle, feel free. You could try them and put them in the assignment. Next week we're gonna be correcting the fractions. We're gonna be correcting this multiple choice here. And next week next class, we're gonna be looking at the ratio and percentage questions, right? And then hopefully we should be done with this beginners section with number theory. Anybody have any questions on what we did today?
No.
You guys understand what we did today?
Yeah.
Well, I hope that you all have a lovely evening. It was nice seeing you all again, and I'll see you guys Saturday at 3, is it?
Yeah, it's 3.
Take it easy.
Bye.
Bye.
Bye-bye.